students, myself Parthasarathi from Saimedha Coaching Center, Koti, Hyderabad. Last Sunday మనకు తెలంగాణ జెన్కో ఎగ్జామ్ ఏఈ ఎగ్జామ్ జరిగింది. ఎలక్ట్రికల్, ఈసీఈ, సివిల్, మెకానికల్. నెక్స్ట్ డే ఇమీడియట్గా ఈవినింగ్ 5 o'clockకి మనకు రెస్పాన్స్ షీట్ కూడా రిలీజ్ చేశారు. అందరు స్టూడెంట్స్ వాళ్ళ ఓన్ పేపర్ని కూడా డౌన్లోడ్ చేసుకొని చూసుకున్నారు. సో యాజ్ పర్ స్టూడెంట్, యాజ్ పర్ ఫ్యాకల్టీ రివ్యూ చూసుకుంటే పేపర్ అనేది ఈజీ నుంచి మీడియం లెవెల్లో ఉంది స్టూడెంట్స్. అంటే కట్ ఆఫ్ కూడా ఈసారి మంచిగా కరెక్ట్గా ఉంటుంది. బట్ ఇక్కడ పోస్టులు అవన్నీ కేటగిరీ వైజ్ చూసుకున్నప్పుడు సీరియస్గా ప్రిపేర్ అయినా కూడా మార్క్స్ 1 మార్క్ 2 మార్క్తో పోయే వాళ్ళు కూడా చాలా ఎక్కువ మంది ఉంటారు. మరి అలా స్టూడెంట్స్ ఉన్నప్పుడు నెక్స్ట్ మనం ఇమ్మీడియట్గా ఒక మంచి పాజిటివ్ స్పిరిట్తో మనం ఏం చేయాలి స్టూడెంట్స్, అదే ఇక్కడ నేను చెప్పాలనుకుంటున్నాను. స్టూడెంట్స్, మనం ఇంత కష్టపడ్డాం, ఈ కట్ ఆఫ్ మార్క్ చూసుకున్నాం, మళ్ళీ ఒక లెక్క చేసుకుంటూ అదంతా టైం వృధా. నాకు వస్తుందా రాదా, లేకపోతే నా ముందు ఎంతమంది, నా క్యాస్ట్ ఎంతమంది ఉన్నారు, అవన్నీ చూసుకోకుండా మనకు ప్లాట్ఫామ్ పైన, అంటే మనకి ఇక్కడ స్క్రీన్ పైన ఎన్నో పోస్టులు, ఎన్నో ఎలిజిబిలిటీస్ ఉన్నాయి టెక్నికల్కి సంబంధించినవి. అప్కమింగ్ జాబ్స్ తెలుసు, ఇంక్లూడింగ్ గేట్ ఎగ్జామ్తో సహా మనం చూసుకుంటే మనకు నెంబర్ ఆఫ్ పోస్టులు ఉంటాయి. గేట్ ఎగ్జామ్ వరకు, ఇంజనీరింగ్ సర్వీస్ ఎగ్జామ్ వరకు మనం అన్నీ చూసుకున్నా కూడా టెక్నికల్ కంటెంట్ అనేది ఒకటే. ఫస్ట్ మీరు ఆ మైండ్లోకి వచ్చేయాలి, టెక్నికల్ కంటెంట్ ఒకటే. ఎస్, నేను ఈ 6 నెలల్లో ఖచ్చితంగా ఒక గవర్నమెంట్ జాబు, అది స్టేట్ గవర్నమెంట్ జాబ్ కావచ్చు, సెంట్రల్ గవర్నమెంట్ జాబ్ కావచ్చు, ఏదైనా కొట్టి తీరుతాను. ఎస్, ఈ ఎగ్జామ్తో నాకు ఒక మంచి కాన్ఫిడెన్స్ లెవెల్ వచ్చింది. ఎస్, మరి ఈ కాన్ఫిడెన్స్ని ఇంతవరకు మనం నేర్చుకున్న దాన్ని వృధాగా పోనీయద్దు. అంటే నీకు ఒక సీరియస్నెస్ ప్రిపరేషన్ కూడా ఉండాలి, ఒక గోల్ కూడా ఉండాలి. అలా మనం చూసుకున్నా కూడా, మన స్టేట్ పరంగా చూసుకున్నా, సెంట్రల్ గవర్నమెంట్ పరంగా చూసుకున్నా, బీటెక్ హోల్డర్స్కి ఎన్నో జాబ్స్ అనేవి వస్తుంటాయి. కానీ సేమ్ టైం కాంపిటీషన్ కూడా చాలా ఎక్కువగా ఉంటుంది స్టూడెంట్స్. ఇవన్నీ మీరు ఒక పాజిటివ్ దృక్పథంతో ఆలోచించి మీరు ప్రిపరేషన్ని ఇంతవరకు మీరు ఎలా కష్టపడ్డారో అదే ప్రిపరేషన్ని మీరు గట్టిగా సాధించండి. మీరు 100% సక్సెస్ అవుతారు స్టూడెంట్స్. ఇంకా మనం చాలా విషయాల గురించి తెలుసుకుందాం. దాంట్లో ముందుగా నేను ఇప్పుడు అనలాగ్ ఎలక్ట్రానిక్స్ జెన్కో ఈసీ వాళ్ళకు వచ్చిన క్వశ్చన్స్ గురించి డిస్కస్ చేద్దాం. క్వశ్చన్ నెంబర్ 19 మాస్టర్ క్వశ్చన్ పేపర్. The DC load line and the output characteristics of a transistor gives the following information except అంటున్నాడు. స్టూడెంట్స్, మనకి ఇక్కడ how you determine DC load line అంటే we know that by using output characteristics. So output characteristics gives relation between output voltage VCE and output current IC. Output voltage VCE, output current IC. Here DC load line, this is the DC load line, and we know that DC load line equation, the slope of the DC load line is -1/RC. ప్రాబ్లం బేస్డ్ లెర్నింగ్లో ఉండాలి. అంటే ఒక క్వశ్చన్ని మనం డిస్కస్ చేస్తున్నప్పుడు ఇక్కడ ఎన్ని పాయింట్స్ వస్తున్నాయో కూడా మీరు జాగ్రత్తగా చూడండి స్టూడెంట్స్. DC లోడ్ లైన్ స్లోప్ ఎంత? -1/RC. సో ఇక్కడ ఏమంటున్నాడు? దిస్ ఈజ్ DC లోడ్ లైన్. ఎస్, DC లోడ్ లైన్. నౌ DC లోడ్ లైన్ అండ్ ద అవుట్పుట్ క్యారెక్టరిస్టిక్స్ అన్నాడు. సో ఐ ఆమ్ కన్సిడరింగ్ హియర్ అవుట్పుట్ క్యారెక్టరిస్టిక్స్ ఆఫ్ కామన్ ఎమిటర్ కాన్ఫిగరేషన్. These are common emitter output characteristics at constant input current IB. At constant input current IB. So question అయిపోయింది. The DC load line on the output characteristics of a transistor gives the following information except. ఇది కాకుండా మిగతా 3 ఇన్ఫర్మేషన్స్ మనం ఈ గ్రాఫ్ నుంచి నేర్చుకోవచ్చు అంటున్నాడు. ఇది కాకుండా అది ఏది అని అడుగుతున్నాడు. There are 4 options given: cutoff point, saturation point, active region, thermal runaway. Yes, ఇక్కడ కరెక్ట్ ఆన్సర్ ఏంటంటే థర్మల్ రన్అవే cannot be determined by using this characteristics with the help of DC load line. And we know that in common emitter output characteristics, here common emitter transistor, common emitter configuration output characteristics can be explained by using three regions: active region, cutoff region as well as saturation region. So here the intersection of DC load line and output characteristic is known as Q point. If Q point is here, then we can determine that is saturation point. If Q point is here, then we can decide that operating point is in cutoff region, and if Q point is here between saturation region and cutoff region, then we can decide that is in active region. So, by using DC load line on output characteristics, we can determine cutoff point, we can determine saturation point, we can determine active region, but we cannot determine thermal runaway. So, option 4 is the correct answer. Next question we are discussing here. Yes. In which of the following region the field effect transistor behaves like a resistor? This is question number 20 and is asking FET characteristics. There are two types of FET characteristics. One is transfer characteristics and second one is what? Drain characteristics, which are also known as output characteristics. So, is asking one question, which region FET can be behaves like a resistor? Is given four options: pinch off region, saturation region, bromic breakdown region and ohmic region. So, all these region can be explained in FET drain characteristics. FET drain characteristics gives relation between drain voltage VDS, drain current ID at constant gate voltage VGS. So, this is FET drain characteristics at constant VGS. Students, here FET drain characteristics can be explained by using three regions. One region name is ohmic region. The region 1 name is what? Ohmic region. This point is pinch off voltage VP and this current is IDSS. VP pinch off voltage, IDSS drain to source saturation current, and what is this region name? Yes, ohmic region, which is also known as linear region. Ohmic region or linear region, and I am considering this point is VDS sat. This region name is saturation region. What is the name here? Saturation region. The region name is saturation region and the region name is after this voltage breakdown region. This region name is breakdown region. There are three regions. One is ohmic region, which is also known as linear region, saturation region, and this is breakdown region. So, in each region FET have some special application. See this region, ohmic region. Why it is called ohmic region? Because in this region FET satisfy Ohm's law. Hence, here current is linearly proportional to voltage. Hence, this region is also known as linear region. In this region, FET can be used as a voltage variable resistor or voltage dependent resistor. Hence, which region FET can be used as a resistor, behaves like a resistor means answer is ohmic region. Ohmic region, which is also known as linear region. Students, now we are discussing next question, question number 21 in master question paper. The cut-in voltage of both GNR diode D2 and PN junction diode D1 shown in figure is 0.7 volts, while the breakdown voltage of GNR is 3.3 volts and reverse breakdown of D1 is 50 volts. the other parameters can be assumed to be the same as those are of an ideal diode, then the value of the peak output voltage V naught is asking. So, according to circuit diagram, again I am considering here input voltage is AC is given, that is a 10 sin omega t. It is given to this circuit like a Genco diode voltage regulator, but not regulator because diode also we are using. Here Genco diode is connected, this is Genco diode, and in series is connected a PN junction diode. Now Genco diode and PN junction diode both are in series. Here we are connecting a load resistor RL. What is the value of this resistor here? 1 kilo ohm. And here this is 1 kilo ohm, this is also 1 kilo ohm, and he mentioned Genco diode with D2, diode D2, PN junction diode is D1, yes, and input voltage is AC voltage, that is 10 sin omega t. What is the input voltage here? 10 sin omega t. This is the circuit diagram, and he mentioned the cut-in voltage of Genco diode and diode PN junction diode is 0.7 volts, and breakdown voltage of Genco diode is 3.3 volts. Students, is given 4 options: 3.3 volts in the positive half cycle, 4 volts in the positive half cycle, 5 volts in the positive half cycle, 0.7 volts in the positive half cycle. See here, we know that this is the symbol of the Genco diode, and this is N terminal, this is P terminal, and this is the PN junction diode symbol, and here also I am explaining this is N terminal, this is P terminal as well as N terminal. Students, when negative terminal of the supply is connected to P terminal of PN junction diode and positive terminal of the supply is connected to N terminal of PN junction diode, then diode is in reverse bias. Reverse చేసేస్తే forward bias. ఇక్కడ ఇవన్నీ ఎందుకు డిస్కస్ చేస్తున్నామంటే, see here I am explaining operation here 2 cases. When input voltage is positive, then Genco diode is in reverse bias. See here, Genco diode is in reverse bias, and we know that Genco diode conducts in reverse bias also because it is a heavily doped PN junction diode. When it conducts, coming to next element, that is PN junction diode, which is connected in series, that is in forward bias. That is which bias? Forward bias. So according to the input voltage, when input voltage is positive, here Genco diode is in reverse bias and PN junction diode is in forward bias. When Genco diode is in reverse bias, then we consider its breakdown voltage, and when PN junction diode in forward bias, then we consider its cut-in voltage. Here he mentioned breakdown voltage is given as 3.3 volts and cut-in voltage is of diode is given 0.7 volts, both are in series, then the voltage is how much? 3.3 volts plus 0.7 volts, that is 4 volts. 3.3 volts plus 0.7 volts, what is the voltage? 4 volts. Now the resistor, load resistor which is connected parallel to this combination, hence the output voltage is also 4 volts. Hence 4 volts in the positive half cycle is the correct answer. Option 2 is the correct answer. Students, next question we are discussing question number 22, and this question is related to transistor biasing. This question is related to transistor biasing. There are 3 types of biasing methods. Here the question is related to self biasing method. We know that it is also known as potential divider as well as voltage divider, and is asking stability factor in self bias circuit, and is given data VCC 12 volts, RC 5 kilo ohms, RE 1 kilo ohm, R1 90 kilo ohms, R2 10 kilo ohms, HFE that is beta 99. Now, what is the stability factor formula here in self bias means stability factor S equals to 1 plus beta by 1 plus beta into Re by Re plus RTH, Thevenin's resistance. What is RTH? Thevenin's resistance. This is the stability factor formula in voltage divider biasing method. Here first to determine stability factor, first we are finding Thevenin's resistance. What is Thevenin's resistance formula here? We know that is parallel combination of R1 and R2, hence R Thevenin is equal to, I am writing R1 into R2 by R1 plus R2. R1 into R2 by R1 plus R2. What is R1 is given? 90 kilo ohms, I am writing 90 K. What is R2? That is 10 K, 10 kilo ohms by R1 plus R2, I am writing 90 plus 10, that is 100 K. 1 kilo cancel, here I am cancelling 2 zeros. So, what is the answer means 9 kilo ohms. Thevenin's resistance value how much? 9 kilo ohms. 1 kilo I cancelled, 2 zeros I cancelled, then what is RTH? 9 kilo ohms. And you consider beta value is 99 here, then stability factor substituting all the given values 1 plus 99, that is beta, by 1 plus 99 into emitter resistor. Emitter resistor value is how much? 1 kilo ohm by emitter resistor 1 kilo ohm plus RTH, that is 9 kilo ohm. So, 1 plus 99, that is 100 by 1 plus 99, kilo cancel, 1 by 10, that is what? 9.9. So, 1 kilo ohm by 10, 1 by 10 means how much? 9.9, 9.9 plus 1, that is 100 by 10.9, 100 by 10.9. We know that 10 tens are 100, but here 10.9 is given, approximately what is the answer means 9.17 is the correct answer, because 100 by 10.9, 10 tens are 100, if it is a 10, the answer is 10 only, and but is given 10.01, because 10.9 is greater than 10, hence we concluded that 9.17, option 1 is the correct answer. Students, next question we are discussing, question number 23. This is also related to BJT biasing. BJT biasing, I am writing BJT biasing. See here the question, the transistor in the given circuit should always be in the active region. Take VC sat equal to 0.2 volts, VB equal to 0.7 volts. The range of RC in ohms which can be used is. This is the question. He is asking what is the value of collector resistor RC. See here, again I am rearrange the circuit diagram, redraw the circuit diagram. This is base resistor, the value is given as 2 kilo ohms, and this is the transistor, common emitter transistor. This is collector resistor RC is asking now, and beta, that is not B, beta is given as 100, beta value is given as 100. Two power supplies are given, this is VBB, VBB, what is the value here? 5 volts, VBB voltage 5 volts, and this is the voltage VCC, what is the voltage here? That is also 5 volts, VBB, VCC is given. Now is asking what is RC. From the circuit, if I apply KVL, output side VCC equals to voltage across RC, that is IC into RC plus VCE, plus VCE. Now is asking RC, VCC already given, VC sat is also given. To determine RC, collector resistor value here, you must know collector current IC. Then how you determine collector current IC means, again I am applying KVL at input side. This is the equation, input side VBB equal to IB into RB plus VBE. IB into RB plus VBE. From this I am calculating IB. IB equal to VBB minus VBE, VBB minus VBE by RB. This is the formula. IB equals to VBB minus VBE by RB. Now what is the value of VBB? That is 5 volts. 5 volts. VBE is given as 0.7 divided by RB 2 kilo ohms. Now that equals to 5 minus 0.7, I am writing 4.3 divided by 2 milliamperes. 2 1 ja 2, 2 2 ja 4, 2 1 ja 2, 5. So what is the value of 5B? 2.15 milliamperes. 2.15 milliamperes. This is IB. But is asking collector resistor RC. To find RC, again I am considering this equation here. I am writing RC equals to, from KVL output side, VCC minus VCE, VCC minus VCE by IC. Now IC I am writing beta into IB, beta into IB. So what is the value of VCC? Here it is given 5 volts, VCC is also 5 volts, and VC is given 0.2. VC is given how much? 0.2 divided by beta value is given as 100 and IB value 2.15 into 10 power minus 3. So 5 minus 0.2 I am writing 4.8 divided by 100 into 10 power minus 3, that is 10 power minus 1 into 2.15 I am writing 0.215. 0.215. If you simplify this 4.8 divided by 0.215, you will get approximately 22 point something. 22 point something will get. That answer is in option 1. That option is in option 1. So the correct answer is collector resistor value lies between 22 ohms to 23 ohms is the answer. Option 1 is the correct answer. Next question we are discussing, question number 24, and this question is related to multi-stage amplifiers. This question is related to multi-stage amplifiers. Yes. See, this is a theoretical question asked here. What is the question? When identical amplifier stages are cascaded, then the overall value of. So this question you can understand easily from gain bandwidth characteristics. So I am considering here two characteristics, single stage as well as multi-stage frequency response. X-axis is what? Frequency, y-axis is gain, frequency versus gain. So first I consider a single stage amplifier frequency response. This is single stage amplifier frequency response, and same graph I am considering multi-stage amplifier frequency response also. Multi-stage amplifier frequency response also. Single stage amplifier, multi-stage amplifier frequency response. See here, this is maximum voltage gain. From this maximum voltage gain we are finding off power points. From here this is lower cutoff frequency FL and this is upper cutoff frequency FH of single stage. Now same thing using multi-stage amplifier. This is maximum voltage gain of multi-stage amplifier and this is off power points of multi-stage amplifier. This is lower cutoff frequency I am representing with FL dash because it is multi-stage, and this is I am considering as FH dash, upper cutoff frequency of multi-stage. FL, FH, lower cutoff frequency, upper cutoff frequency of single stage, FL dash, FH dash are lower cutoff frequency and upper cutoff frequency of multi-stage. See here, I am writing this point also here. This is multi-stage amplifier frequency response. Multi-stage amplifier frequency response. This is single stage amplifier frequency response. Single stage amplifier frequency response. Now coming to our 4 options. Option 1, lower cutoff frequency is lower than of an individual stage. That means is considering FL dash is less than FL, but the statement is wrong because see from this graph FL dash greater than FL. Second statement, lower cutoff frequency is higher than, yes, second statement correct. Next statement also I am observing, higher cutoff frequency is higher than of individual state. See, higher cutoff frequency means FH dash. See this graph, FH dash higher cutoff frequency is not greater, it is less than of individual stage of higher cutoff frequency. And bandwidth, see FH minus FL, bandwidth of single stage, FH dash minus FL dash, bandwidth of multi-stage. Out of these two, by using multi-stage, bandwidth will be decreases. So, option 1 wrong, option 3 wrong, option 4 wrong, only option 2 is correct, that is lower cutoff frequency is higher than of individual stage lower cutoff frequency. Students, next question we are discussing. Next question is question number 25. The restorer is, this is a simple question. This question 4 option is given: clipper, clamper, summer, rectifier. It is not rectifier because we know that rectifier is a circuit which converts an AC input voltage into pulsating DC. This is not summer. See, restorer in clipper, clamper, which is restorer? Yes, answer is clamper. Clamper is also known as DC inserter. DC inserter, which is also known as restorer. Restorer, because we are using a capacitor to perform clamping operation, that is restorer. A DC value is restoring there, by with respect to that we are performing clamping operation. Same thing, clipper is also known as limiter, slicer, but here is asking restorer. The correct answer is what? Clamper. Students, next question we are discussing, question number 26. The transconductance of the transistor GM is given as 10 millimhos. 10 millimho. Now is asking the input resistance R input. Here we consider high frequency hybrid pi model of transistor. Then there is a formula RB dash E, that is input resistance. RB dash E equal to formula beta by GM. Beta by GM. Beta value is given as 50 and GM is given as 10 milli. 10 into 10 power minus 3, that equal to what is RB dash E value? 5 kilo ohms. Here RB dash E value is 5 kilo ohms. So, if you observe this high frequency hybrid model, this is RB dash E and we are using voltage divider biasing. RBB dash I am considering RBB dash E, both are in parallel. I am considering here this RBB dash I am considering R1 parallel R2, and what is R1 is given 10 kilo ohms, 10 into 10 power 3, R2 is also given 10 kilo ohm, 10 into 10 power 3 divided by 10 plus 10, 20 into 10 power 3. 1 10 power 3 kilo will be cancelled, 10 1 ja, 10 2 ja, 2 1 ja, 2 5 ja. So, what is this value? 5 kilo ohms. Both 5 kilo ohm resistors are in parallel, then the parallel combination gives its input resistance of transistor. What is the value here? 2.5 kilo ohms is the answer. Option 4 is the correct answer, students. Next question we are discussing 27. This question is related to operational amplifier, op-amp. Operational amplifier. See here, the value of feedback resistance for an op-amp with gain of minus 10. That means understood that the operational amplifier is in inverting mode. and input resistance equal to 10 kilo ohm. So here I am considering operational amplifier using inverting mode. This is the symbol of op amp. This is the symbol of op amp. Now inverting mode means what? Input voltage Vi is given to inverting input terminal. This is input voltage Vi. Input voltage Vi is given to operational amplifier. This is input resistance Ri. Now here I am connecting a feedback resistor Rf. I am connecting a feedback resistor Rf and this is ground. So this is output voltage, this is plus Vcc, this is minus Ve. This is the circuit diagram. Now is asking what? Rf value is how much? Rf value how much? When voltage gain is given as minus 10. In inverting mode operational amplifier, gain V naught by Vi equal to what is the formula? Minus Rf by R1. Minus Rf by R1, that is gain formula. So here gain value is given as minus 10, that equal to formula already minus is there, is asking Rf and what is the input resistance is given 10 kilo ohms. So minus minus will be cancelled and what is Rf now? 10 into 10, 100, answer 100 kilo ohms is the answer. Option 4 is the correct answer. This question is related to operational amplifier. Now this is question is also operational amplifier applications of op amp. There are so many applications we discussed in BTech, applications of op amp. This is a standard question. This is a standard question. We discussed in classrooms also. This is the applications of RC networks using op amp. So when the input voltage applied to operational amplifier through a capacitor, then it is high pass filter. If the feedback element is a capacitor, then it is a low pass filter. So what is the correct answer? It is a low pass filter. Option 1 is the correct answer. Next question. This is oscillator related question. Oscillator related question. What is the question? The equation for frequency of oscillation of Wien bridge oscillator using op amp. Using transistor, using op amp, formula is same. What is the Wien bridge oscillator frequency formula? F naught is equals to 1 by 2 pi RC hertz. Sometimes is asking in terms of omega naught also, where omega naught equals to 2 pi F naught, that equals to 1 by RC radians per second. So what is the correct answer here? Option 2 is the correct answer. The frequency of Wien bridge oscillator using op amp is what? 1 by 2 pi RC hertz. And next question we are discussing a wide band pass active filter. This question is also application of op amp. Gain is given as 4 and F1 is given as 20 hertz, F2 is given as 2 kilohertz. Then is asking find the value of quality factor. Here quality factor formula in terms of frequency F naught by F2 minus F1. F2 minus F1. F2 is given as 2 kilohertz. This is F2. F1 is given as 20 hertz. But we know that a band pass filter, this is the frequency response of band pass filter. This is the maximum gain at frequency F naught. With respect to that, this is F1, this is F2. So what is the relation between these three frequencies? F naught, F1, F2 means they are in geometric mean. F naught equals to under root of F1 into F2. F naught equals to under root of F1 into F2. I am finding first F naught. F1 is given as 20 hertz. F2 is given as 2 kilohertz. So 2 2 ja 4 and 10 power 3 into 10, that is 10 power 4. Root 4 I am writing 2 and 10 power 4 I am writing 10 square. So what is F naught value? 2 into 10 square. So I am substituting here 2 into 10 square divided by 2000, that is 2 kilohertz, minus 20. 2000 minus 20, how much? 0, 10 minus 2, 8, 1980. So 200 divided by 190, 1980 cancelling. So if you simplify this answer, you will get 0.1010. So what is asking? Quality factor is 0.10. Simple band pass filter, wide bandwidth consists low, quality factor is low. So option 1 is the correct answer.